4.2 Estimating the coefficients of the linear regression model. In a practical situation, such as the application to class size and test scores, the concept beta sub naught and the slope beta sub 1 of the population regression line are unknown. Therefore, we must use data to estimate these unknown coefficients. This estimation problem is similar to those faced in Chapter 3. For example, suppose you wanted to compare the mean earnings of men and women who recently graduated from college. Although the population mean earnings are unknown, we can estimate the population means using a random sample of male and female college graduates. Then the natural estimator of the unknown population mean earnings for women, for example, is the average earnings of the female college graduates in the sample. The same idea extends to the linear regression model. We do not know the population value of beta sub class size. The slope of the unknown population regression line relating to big X of class size and big Y of test scores. But just as it was possible to learn about the population mean using a sample of data drawn from that population, so it is possible to learn about the population slope beta subclass size using a sample of data. The data we analyze here consists of test scores and class sizes in 1999 in 420 California school districts that serve kindergarten through 8th grade. The test score is the district-wide average of reading and math scores for 5th graders. Class size can be measured in various ways. The measure used here is one of the broadest, which is the number of students in the district divided by the number of teachers. That is the district-wide student-teacher ratio. These data are described in more detail in Appendix 4.1. Table 4.1 summarizes the distributions of test scores and class sizes for the sample. The average student-teacher ratio is 19.6 students per teacher, and the standard deviation is 1.29 students per teacher. The 10th percentile of the distribution of the student-teacher ratio is 17.3. That is, only 10% of districts have student-teacher ratios below 17.3, while the district at the 90th percentile has a student-teacher ratio of 21.9. See Table 4.1, summary of the distribution of student-to-teacher ratios and 5th grade test scores for 420 K through 8 districts in California and in 1999. So we have the student-teacher ratio and test score on the first column, then the average, standard deviation, and the percentiles, 10, 20, 40, 50, which is the median, 60, 75, and 90. And in figure 4.2, it's a scatter plot to test scores versus student-teacher ratio, California school district data. Data from 420 California school districts. There's a weak negative relationship between student-teacher ratio and test scores. The sample correlation is negative 0.23. Vertical axis test scores, horizontal axis student-teacher ratio.